Hello. This video is going to show how we can measure structural coverage on software that's running on FPGAs. Now, there's a lot of different FPGAs available today. For instance, I could show it working with the Intel Quartus and Neos 2. I could show it with Microsemi, that's now a microchip company. I could have shown this running with the soft console on a Smart Fusion 2 board. I could have shown it with Synopsys Arc Metaware. With one of their boards. Or I could have shown it with a Cypress PSOC creator on a PSOC 6 or 5, for instance. But in this particular case, I'm going to demonstrate the integration with Xilinx. And I could have done it with a Xilinx using a microblaze, a soft core CPU. But what I'm going to use is one of the more popular boards, and that is a Xilinx Zynq. And in this particular case, I've got this board connected to my PC at the moment. This is a MiniZed that's running a single Cortex A9. Okay, so this is the Xilinx SDK. I could have shown this with the newer IDE, Vitis, but in this particular case, this is the more popular at the moment. And I've got a number of projects here. This is the one that I'm particularly interested in. What I want to do is to effectively execute this on the target and measure the coverage. And as we can see, I've got a simple main, and it's C++ code. It's looping around a certain number of times, and it's basically manipulating a static linked list and a dynamic linked list. So it runs for a certain number of time and then exits. Well, let's just build this and we'll execute it. So let's go and do a build. Looks like it's already built. And now let's go and debug this. So it's important to debug it once because that's actually going to generate a script, and this script is what LDRA is going to use in order to be able to control the execution. So there we can see it's downloaded to the target, and now I should be able to start single stepping through the code, doing whatever I want to do. I'm just going to let it run until it gets to the end. Okay, so that was fairly straightforward. Let's stop the execution here. So terminate that, and we'll do this. And now let's go to the next tool that I want to use, and that is going to be the LDRA launcher. And in the LDRA launcher, I'm going to start this build import, because what I want to be able to do is to run the build. And so I've basically got a build.bat file that will do that for me. And I'm simply going to execute the build. And as that performs the build, we're going to listen to what it's done. And from that, we're going to be able to get a list of basically the executable that's generated, a list of the source files. We'll get all the include paths, as well as any preprocessor symbols. And now we have everything we need in order to be able to analyze the code, and I can simply click here and open it with TB Vision. Well, I've already got it open inside TB Vision, and if I just switch to TB Vision, there we can see I've already analyzed this code, and there we have all the files. So let's put it into a class view, and there we can see we've got a number of namespaces. Right, so what I want to be able to do is to actually execute this on the target. So to do that, I'm going to go and instrument the code. I'm going to put probes in around all the branches. I'm going to build it. I'm going to execute it, and then measure the coverage. So let's start the analysis. So inside this window, we're going to see it start to do the instrumentation. Then it's going to perform the build. So there we can see it's building it, and now it's executing on the target, and it's using the same script that was generated when we executed it for the first time inside of the IDE. So that's now connecting to the board, and now we're running a second script here that's effectively managing to control the execution, getting data off the target, and here we can see we're starting to analyze the execution history. And we're going to be able to take a look and see, well, what coverage did we obtain as we executed this simple main here. So just need to wait for that to finish. And now we're going to be able to take a look, and we'll go to a test manager report, and we'll see what actually happened there. So maximize this, code review, quality review. Well, I've not looked at that. I'm concerned here with the coverage. And as we can see, we've got some pretty good coverage for some of these files. Node, we haven't got that much coverage. But let's take a look at the static linked list, and we can see we've had one run so far. And if we scroll down, we can see, well, this coverage is pretty good. We've got statement and branch coverage. There's no MCDC inside this particular class. But we can see, if we take a look at add last, that we've only got 88% coverage. We can see here that we've never executed these lines of code because we've never had free node equal to null. So if I want to get complete coverage for this, I can actually use the unit testing tool tbrun to do that. So let's invoke tbrun. And inside tbrun, I'm going to first of all maximize this. And then I'm going to open a sequence that I've created previously. So here I've got a number of sequences, and let's test the node one first. Let's just open that, and then we get full coverage on this. So there we can see a number of tests. The first one creates a constructor, creates an object, and the next one's test the function is null. And in each case, I'm trying with different inputs and checking the output. So let's run this and see what happens. So that's now performed or generated a harness. It's performed the build. It's now connecting to the target, and it's running the script on the target. So wait for it to connect to the target. There we go. It's connected. And now we're capturing the information. And there we can see all the tests have passed. We're now going to look at the coverage. And hopefully we'll have increased the coverage from 22% statement coverage to 100%. Let's just wait for that to finish. Okay, almost there. And there we can see, yes, we've got 100% statement coverage, branch decision coverage, and also on that particular class, we've got 100% MC-DC coverage. So finally, let's take a look at our class for the more complicated, and that was the static linked list. So again, I'm going to open a new sequence here that I've created previously. So for the static linked list, and this is a lot more complex. So you can see here there's a static linked list of 16 nodes. So each time I'm calling it 17 times, and I'm removing it, adding at the start, removing the start. Let's just run this and see what happens. So okay, that's generated a harness. It's built it. Once more, we're going to download it to the target. So again, we can see here it's connecting. And then it should start to run my script. Okay, so there it's now starting to run my script. We're hitting breakpoints, we're capturing the information we want, we've got the data back, and most importantly, we can see the test of all passed. And if we scroll back up here, we should be able to take a look at our static linked list, and hopefully we should end up with 100% statement and 100% branch decision coverage for this class here. So once more, just need to wait a little bit of time, and there we can see, yes, we've got 100% coverage of that class. And if you need more information, then please don't hesitate to contact LD Ray.